Good day, sir. I am Cadet 3rd Class Margarico George D. BSME 2 Charlie. So my report is evaporator unit. So an evaporator, distiller or distilling apparatus, is a piece of ship's equipment used to produce fresh drinking water from seawater by distillation. As fresh water is bulky, may spoil in storage, and is an essential supply for an longer voyage. The ability to produce more fresh water in mined ocean is important for any ship. So combined supply of evaporator. The first distilling plants that built a separate water supply from that of the main boiler appeared around 1867. These were not directly heated by a flame, but had a primary steam circuit using main boiler steam through coils within a steam drum or evaporator. The distillate from this vessel then passed to an adjacent vessel, a distilling condenser, as this evaporator used a clean seawater supply directly, rather than contaminated water from the boiler circuit. They could be used to supply both feed water and drinking water. These double distillers appeared around 1884. For security against failure, ship accepts the smallest were fitted with two sets. So the first is vacuum evaporators. So evaporators consume a great deal of steam and thus fuel. In relation to quantity of fresh water produced, their efficiency is improved by working them at a partial vacuum supplied by the main engine condensers. On modern diesel-powered ship, this vacuum can instead be produced by an ejector, usually worked by the output from the brine pump. Working under the vacuum also reduces the temperature required to boil seawater and thus permits evaporator to be used with lower temperature waste heat from the diesel cooling system. Next is scale. One of the greatest operational problems with an evaporator is the build-up of scale. Its design is tailored to reduce this and to make its cleaning as effective as possible. The usual design as developed by Weir and the Admiralty is for a vertical cylindrical drum heated by steam verticals heated from steam carrying round coils in the lower portion. As they are entirely submerged, they avoid the most active region for the deposition of scale, around the waterline. Each coil consists of one or two spires in a flat plane. Each coil is easily removed for cleaning, being fastened by individual pipe unions through the side of the evaporator. A large door is also provided, allowing the coil to be removed or replaced. Cleaning may be carried out mechanically with a manual scaling hammer. This also has a risk of mechanical damage to the tube, as the slightest pitting tends to act as a nucleus for scale corrosion. Next is compound evaporators. Operation of an evaporator represents a costly consumption of main boiler steam, thus fuel. Evaporator for a warship must also be adequate to supply the boilers at continuous full power when required, even though this is really required, varying the vacuum under which the evaporator works, and thus the boiling point of the void water may optimize production for either maximum output or better efficiency, depending on which is needed at the time. Greatest output is achieved when the evaporator operates at near atmospheric steam. This will be at limit of 100 Celsius, which may then have an efficiency of 0.87 kg of feed water produced for each kilogram of steam supplied. Next is evaporator pumps. The unevaporated seawater in an evaporator gradually becomes a concentrated brine, and like the early steam boilers with seawater feed, this brine must be intermittently blown down every 6 to 8 hours and dumped overboard. Early evaporators were supplied simply mounted high up and dumped their brine by gravity, as the increasing complexity of surface condenser demanded better feed water quality. A pump became part of the evaporator equipment. This pump had three combined functions as a seawater feed pump, a pump, each of progressively smaller capacity. The brine salinity was an important factor in evaporator efficiency to thence encourage scale formation, but too little represented a waste of heated seawater. The optimum operating salinity was thus fixed at 3 times that of seawater, and so the brine pump had to remove at least one third of the total feedwater supply rate. The uses of evaporator: air conditioning and refrigeration. Some air conditioners and refrigeration use a compressed liquid with a low boiling point that vaporizes within the steam system and cools it, while emitting the thermal energy into its surroundings. Food industry and synthetic chemistry. Evaporators are often used to concentrate a solution. One example is the climbing falling film plate evaporator, which is used to make condensed milk. Similar reduction is a process of evaporating liquids from a solution to produce a reduced food product such as wine reduction. Evaporation is the main process behind distillation, which is used to concentrate alcohol, isolate liquid chemical products, or recover solvents in chemical reactions. The fragrance of essential oil industry uses distillation to purify compounds. Each application uses specialized devices. Next is chemical engineering. In the case of desalination of seawater or in zero liquid discharge plants, the reverse purpose applies. Evaporation removes the desirable drinking water from the undesired solute product or salt. Chemical engineering uses evaporation in many processes. For example, the multiple effect evaporator is used in craft pulping, the process of producing wood pulp from wood. Next is marine. Large ships usually carry evaporating plants to produce fresh water, reducing their reliance on shore-based supplies. Steam ships must produce the high-quality distillate to maintain boiler water levels. Diesel engine ships often utilize waste heat as an energy source for producing fresh water. In the system, the engine cooling water is passed through a heat exchange where it's cooled by concentrated water. Because the cooling water, which in chemically treated fresh water, is a temperature of 70 to 80 Celsius, it would not be possible to flush off any water vapor unless the pressure in the heat exchanger vessels drop. Next is type of evaporator unit. Evaporators work using the same principle design. A heat source is in contact with the liquid, causing it to evaporate. The vapor is removed entirely like in cooking, or it's stored for reuse like in a refrigerator, or a product for isolation, essential oil. Next is rotary evaporator. Rotary evaporator uses a vacuum pump to create a low pressure over a solvent while simultaneously rotating the liquid flask to increase surface area and decrease bubble size. Typically, the vapor is passed over a cold finger or coil so that the vaporized material does not damage the pump. The rotary evaporator is best used for removing solvent from solution containing the desired product that will not vaporize at operating pressure to separate the volatile components of a mixture from non-volatile materials. Next, natural force circulation evaporator. So natural circulation evaporator are based on the natural circulation of the product caused by density differences that arise from heating. A chamber containing a solution is heated and the vaporous liquid is collected in a receiving flask. Falling film evaporator. This type of evaporator is generally made of 4 to 8 meters tubes enclosed by steam jackets. The uniform distribution of the solution is important when using this type of evaporator. The solution enters a change velocity as it flows downward. This gain is velocity as attributed to the vapor being involved against the heating medium, which also flow downward. This evaporator is usually applied to highly viscous solutions, so it is frequently used in the chemical, sugar, food, and fermentation industries. Next is rising film evaporator. This type of evaporator is useful in concentrating a solution. The operation is very similar to that calandria, where the liquid is boiled inside vertical tubes by applying heat to the outside of the tubes. The produced solvent vapor presses the liquid against the walls of the tubes, forming a thin film that moves upward with the vapor. The vapor may be released from the system, where the liquid may be circulated through the evaporator to further concentrate the solute. Climbing and falling film plate evaporator. Climbing and falling film plate evaporators have relatively large surface area. The plates are usually corrugated and are supported by the frame. During evaporation, steam flows through the channels formed by the free spaces between the plates. The steam alternately climbs and falls parallel to the concentrated liquid. Multiple effect evaporator. Unlike single stage evaporator, this evaporation can be composed of 7 evaporator stages. The energy consumption for a single effect evaporator is very high and is most of the cost of an evaporation system. Putting together evaporators saves heat and this requires less energy. Adding one evaporator to original decreased energy consumption by 50%. Adding another effect reduces it to 33%, and so on. A heat saving percent equation can estimate how much one will save by adding a certain number of effects. The last is agitated thin film evaporators. So the agitated thin film evaporator has been very successful with difficult to handle products. Simply stated, the method quickly separates the volatile from the less volatile components using indirect heat transfer and mechanical agitation of the flowing product film under controlled conditions. The separate is normally made under vacuum condition to maximize, while maintaining the most favorable product temperature so that the product only sees equilibrium conditions inside the evaporator and can maximize volatile stripping and recovery.